Why don't we feel Earth's rotation, even though it's spinning at 1600 km/h? At the equator, Earth rotates at 1600 km/h, approx. 465 ms. Yet we feel no sensation of spinning, movement, or force. This seems strange until we dive deep into the laws of physics, reference frames, and sensory limitations. Let's approach this in 7 scientific layers, each building up to a full understanding. Newtonian inertia and the principle of constant velocity. Key concept: Newton's first law: an object in motion will remain in motion unless acted upon by an external force. If you're moving at constant velocity in a straight or circular path and there is no acceleration, you will not feel that motion. This is known as inertial motion. Application to Earth. The Earth rotates smoothly and constantly, not accelerating or decelerating. There are no jolts, stops, or irregularities in rotation. So there's no external force acting on your body to signal motion. Just like flying in a plane at cruising altitude and constant speed, you don't feel movement because everything inside is moving at the same speed. Earth as an inertial reference frame. What is a reference frame? A reference frame is a coordinate system you use to measure motion. On Earth, we treat our surroundings as stationary because we're moving with it. Earth is a non-inertial rotating reference frame, but it's effectively inertial for most human activities due to how stable it is. Imagine standing in a train that moves at constant speed on a straight track. If the windows are closed and there are no vibrations, you can't tell you're moving. You feel motion only when the train speeds up, slows down, or turns. All forms of acceleration. Earth's surface behaves the same way. No detectable acceleration. So we feel stationary. Co-rotation and uniform motion, we're not still. We are moving with Earth. You are rotating at 1600 km/h. But so is the air around you, the chair you're sitting on, the buildings, oceans, trees, everything. This is called co-rotation. Since everything shares the same velocity, there is no relative motion between you and your environment. In physics, motion only matters when it's relative. You only feel movement when you move relative to your surroundings, which isn't happening. Why the wind doesn't blow at 1600 km/h? This is a common misconception. If Earth is spinning, why doesn't the air rush past us? Answer: atmosphere rotates. 2. The atmosphere is gravitationally bound to Earth. It was formed while Earth was spinning, so it inherits the same angular velocity. There is no wind from Earth's rotation because we, the ground and the atmosphere, rotate together. Only local pressure differences, not global rotation, create wind. So, Earth's spin doesn't create giant winds because everything, land, water, and air, are moving together. Centrifugal force, gravity, and the equator. While we don't feel Earth's rotation, there are measurable physical effects of centrifugal force due to rotation. Earth creates a weak outward directed force called centrifugal force. It slightly reduces your weight at the equator. At the equator, you weigh 0.3% less than at the poles. This is because the centrifugal force cancels a bit of gravity's pull, but this is too small to be felt by our senses, constant, so we adapt to it from birth. The Coriolis effect and observable evidence even. If we can't feel Earth spin directly, we observe its effects. Like Coriolis effect causes cyclones to spin clockwise in the southern hemisphere and counterclockwise in the northern, a direct result of Earth's rotation deflecting large-scale motion. Foucault's pendulum. A long pendulum will slowly change the direction of its swing over time. This rotation proves Earth is turning beneath it. Earth's oblate shape. Earth is not a perfect sphere. It bulges at the equator due to rotational centrifugal force. These are scientific instruments and phenomena that confirm Earth's rotation, even though we don't feel it. Why humans can't sense constant rotation? Our bodies have vestibular systems in the inner ear, which sense changes in acceleration, not constant motion. They detect turning, spinning, falling, but only if it's changing. Since Earth's rotation is very slow in angular velocity, 15 degrees per hour, Perfectly steady, present from birth. So we're completely adapted. We have zero sensory input to detect it naturally. Final physics-based summary reason, scientific explanation, constant rotation, no acceleration, no sensation, Newton's first law, co-motion, everything moves with Earth, no relative motion, no reference, no external cues to indicate spinning atmosphere rotates too, no wind from rotation, air co-rotates weak centrifugal force, slight weight difference, not enough to feel, no sensory organs for it. Vestibular system can't detect slow, constant spin observable effects. Pendulums, Coriolis effect, Earth shape, prove rotation bonus. Thought experiment. If Earth suddenly stopped spinning, you'd feel it violently. Everything not bolted down would fly eastward at 1600 km/h. Oceans would rush across continents. That's how fast we're moving. But only noticeable if the rotation stopped.